Yes. Okay. Good. We have sound. Sorry about that. There you go.
Yes. And I take a short summary why we need to classify and identify. That's because the laws and regulation about how to build a building is used by people that have other needs than the people that's using the buildings. Here in Norway, we have different laws and regulation for how to use a building right and safe. So we use some of the information, but we use it for other purposes. And that's why we have also to identify some of the information. Also, who is utilizing the information here? Most people say that's a janitor that needs the information about the building. He or she uses about 7% of the information, but the other shareholders, the government authorities, the entrepreneurs, the users, so on, use a lot more of the information for their purposes, the bank, insurance, and so on. This is an old report. I think it's from 2002, but this says that non-efficient gathering of information will cost us. It will cost us today about €2 per square meter per year in the building life cycle. That's costs because we switch instead of repairing. That's cost of having to go to the building to see what sort of lamps we have, to go out to the shop and buy a new one. So €2 per square meter per year. The standards I'm going to talk about is based on ISO 12006-2. So this is connected and will be easy to have mapped. We have to see a lot of standards as a whole. A lot of people using the standards work in one or two and don't see the scope that they have to see it together and mapped with other standards. And that's what we are going to talk about today. Also, the standards we are working with, we had some questions here if we're going to go down memory lane today. The standards are made to work analog and digital. So that's some of the issues we have to address. You can use the standards if you are on paper. That's not that cost efficient. You can use digital computer systems and more analog BIM models. To use the standards, we have to know some of the terms. We are going to look at the Norwegian standard 3451 that's addressing and have tables for building elements, parts for buildings. We are going to talk about the standards with the components. That's when I take the building parts and sort them and start to classify and identify. And the tables for systems and buildings. When I take the components and build systems, and I take the systems and build buildings. As a whole, this set of standards are like the 3451 that I'm going to present now is the structure. It's how we use the classification numbers to in 10 other standards on the same base. 3456 is a standard for what information that should be delivered with a building. The 3457 series is classification, identification, and labeling. And Steen will talk about the 8360 standards, about the visualization and the BIM models. And of course, 9650 as a process. 3451, first edition was in 1984, so we have used this for a long time, and the entrepreneurs, the janitors, and so on are used to this standard, and they know a lot of the numbers in the standard. They don't always know that they're working in the standard, but they know the numbers. The last edition, 2022, also added codes for systems. It has been building elements, and it has been used as system codes, but it's not been standardized before now. So we have a lot of 8 tables where we have the numbers for building elements. It's down to 4 digits in granulation, and here the examples, 23 is exterior wall, and the 3rd digit is load bearing, not load bearing. So this is building elements used for building load bearing exterior walls. When you used the building elements and build the systems, you have these codes. That's the codes for the systems. So here you see the building elements 231, and the system, wall system, is 2310. One extra number. Except from, I think, 2 systems, they all end on 0. But we had some extra the requirements for ventilation systems, so you have an extra, you have a 3605 for war ventilation. So yeah. And we also have the standards associated with outdoor areas to the buildings. So the whole 7 series is outdoor. So this is drainage systems, outdoor stairs and ramps and so on. The indoor stairs are in the 2 series. As I said, the 3451 is a base for several other standards. So now I'm going to show how it's used in 3456. That's the standard for documentation for management, operation, maintenance, and development of buildings. The laws and regulations are telling that you have to deliver enough information. And then in the different standards for how to build sprinkling system, fire alarm systems, there are specified what to deliver to this system. The 3456 is handling as a top umbrella all the standards. Whatever standard you're using, you have to deliver information about the system, about the components, about the identification, drawings, and so on. So here also to provide information to all the users. Here in this standard, we have a 3-digit in the 1 series. That's a beginning archive key. This was actually asked from the Norwegian armed forces. And here we have standard numbers for the contracts, warranties, legal public documents, numbers for the drawings. This is the information that are about the system. So this is information about the building, the plot, the site, so on. Yeah, the letters here, this is the information types, yes, and some of this information is gathered during use of the building, but this is the total key. And the letters on the left are telling if it's a contract delivery or if it's official that you have to do it because it's in the law. Yeah, so you have extra letters here. Working with this standard, we had a long discussion of what to deliver. We had, I think, 900 different document titles. That was distilled, so we have 11 information types. Information type compliance and achievement of requirements. How have you achieved the requirements in the laws and regulation or in the contract? If I order ventilation or electrical guide, vad heter föringsväg? But I need 30% extra capacity. How have you solved that? You have to deliver information about that. That can be written, it could be pictures and so on. You have the information for the operations, information for maintenance, identification, product information. Some of the building has to have a third-party control, and also the information for the user, the end user. This information, operations, is for the janitor, one with an education. As a public user of the building, how to use this room with the lights, computers, that's end user information. That's an information type as its own. Here you see I use the same numbers as in 3451. I have the system, electrical heating system, with information types required for the system. And here, this is the information for the components used in the system. So I have to read these lines together. Information about the components, where they're from, what they can deliver, the color type. But here, how does this work together? Here is short what I told earlier. This is the standard for sprinkling systems. So here is the requirement for what you have to deliver to this system. This is the fire alarm. This is another standard, what we have to deliver. But 3456 will take these three standards together. And also there are some problems about the integrated systems. So here, information about that component in the fire alarm will also has to be addressed to the information about, for example, the doors that are responding to the fire alarm. Yeah, here is some of the issues. We have the table with the building elements, but in the BIM and other systems, we are talking about components that are categorized and identified by other codes. So from the building parts to the components, we have also mapping systems. Here, I have the building parts 2442 doors. That's the component types, but also can see what is called in IFC, in 813346, and so on. So this is mapping is a table we are working with in the standard Norway system. The 3457 series are developed to covering classification and identifications. The hierarchy 3457-2, that's a plan standard. It may be covered in 81346, but the construction complexes, that's hospital areas, army areas, training areas, so on. So that's the farm and plot numbers. Could be. The building types, so the buildings on the complex, school building, barracks, hospital building, and the building contains systems that contains components. The building also can contain rooms, floors, and zones. So spatial standards or technical standards. Standards used to identify. Who am I or how am I identified? You can see me in different scenarios. You can Google me. You have a lot of mail accounts. You have member accounts and so on. But the social security number is the one common. So using the 3457 series, we can identify. Here you see codes from the complex, code from building standards, system standards, component standards. So here I have as a buffer number 333 in ventilation system number 14, the tour part, out part of the ventilation system in building A on the complex 200-408. That's a school in Oslo. Building 11, ventilation system number 14, buffer number 333, buffer type number 8, subgroup 6, and this is for special functional. So this, in this example, I have a buffer that's going to react on the fire alarm. We use the same syntaxes as in the ISO 81346, so we can also map that way. Example, the red here, Nadderud Stadion, that's a sporting area with building and built environments. So going down, I have planting systems, outdoor, equipment systems, that's playground systems and so on. And I also have the codes for the buildings on the plot. Built things versus buildings. This seating here, that's a tribune, built entity. So this is to the plot, Nadderud Stadion. It's outdoor, and it's system 7750 tribune. This one has a ceiling, so this is a building, the same plot, but building A, that has a building type 654. The component standard -8, also 3 letters. So opening components, and here on the 3 letters, fire-rated doors or bollards, raise and lower. So they are both opening, but are different component types. To what purpose do I use this? And in operation, if I have a deviation on a specific door, that's the door number. Here, door number 1 in this building on this plot. If I want someone to inspect the fire doors, I have the type here, the fire doors. If I want to test the function of all the doors that are going to close or open by fire alarm, that's the functional part. If I want to replace the door, that's the subgroup of the component type. That's if it's a group of the same type of door. If it's a serial door or unique door, I also can connect it to this component. And this is the system, the doors that are working together in this building. Also, to identify or find the rooms here, Mølladammen School, type, education, building D, gymnasium, room number from an ISO standard, and a type shelter room. So using these codes, when the war starts, the government can find out how many shelter rooms do we have in Norway, if all uses these standards. How big it is from the 3940 standard, the capacity from the regulations and laws, the equipment identified and classified by these standards, how to maintain and use the building by the information delivered, and how to presentate it with BIM or flat drawings. And using the codes of the rooms in the facility management, if I have built a shelter room, but I use it as a library or a room for hazardous substances, this will tell me in which order I have to clear the rooms if I have to use them. So the spatial units, we have the room types in 3457-4, the room naming, and the zones. The zones can be public zones, toll zones, cold zones, hot zones, or also the zones for the matricular units. 3457-9 uses the previous standards and are addressing how to label the systems and components in the building. So this standard is from 21. The building I work in has the old or the previous edition, but this is how the components is labeled following these standards. And here, the red one, that's above the ceiling. We also have a fire detector above the ceiling, and this one has its own address on this label.
Gunnar's not finished, so he will have the final word anyway. So good morning, everyone. My name is Steen, the pointer. The reason why I'm here is because I've been convener of the committee producing the series of standards 8360 NS for Norwegian standard with the overall title, all of them objects for construction. So they are meant to include both buildings and infrastructure. The group working has mainly been building people, so it's a lot of issues from the building perspective, but we're getting infrastructure people into this. My presentation will also tell you about how we are utilizing identification, also some classification, but especially identification. But I'm actually going to drag you through the content, at least the highlights of the series. So hang on, buckle up. It's going to be relatively tight with information here. Of course, when we do this, it's all IFC. So actually, we don't use the IFC except from referencing as a normative standard in the beginning of each standard. When we started, it was the first version was mainly we had practice from 2x3. And we were awaiting the IFC4. Now we actually have IFC4 and using that. This is all open BIM, and we don't invent anything that is already covered by buildingSMART International and the ISO standards, of course. We are also in accordance with the 19650, especially the terminology and principles from part 1. There, just to have that clarified. Why we need to have these clarification is that actually both 19650 and especially also IFC, the international standards, they do not cover all the practices that we have in Norway. And you have seen examples, good examples on how you have standardized those practices over many years in Norway. Now we also need to see how we can connect the practice today in Norway with those new tools that IFC and the buildingSMART and Open BIM standards provide to us. So we need some clarification so we have a common foundation to innovate, and we don't have to agree on everything in every project that we start. So the standard series was started, I think the work was started in 2010-11. I started as a convener in 13. The first version that is actually expired was way back in 2015. That is replaced now by part 1, and we have split it, and then we have also for properties for identification, which is very much aligned with what you see, the identification that Gunnar showed you, and I'm going to show you a little bit of how we regulate that in work. The bold text means that it is published. Here you see, because it's actually, I didn't check this morning, so it may be published. I know it's in production because we have actually split this Norwegian properties out as a guide for itself, so we can update it more frequently. And we are also working on final touches of referencing how we connect model with documentation, very much aligned with the how we work with documentation for FM and operation and maintenance. We are also working or preparing a hearing for energy analysis, and then we are also seeing into guidelines with interface between GIS and BIM. So the first part, which is relatively old, updated a couple of times, but it actually takes some of the modeling practice that we see that is simply good best practice in Norway, advised practice, and put it together. So it regulates the part if you have object libraries or what goes on between authoring or analysis tools or viewers and so on. It doesn't really regulate what's going on the proprietary side. So that's relatively easy. Actually, we also tried to see if there were any difference between whether you were software vendor, object library vendor, or software user, to what extent you should know about this, or you should actually deliver upon the requirement. Actually, in the latest version, we actually agreed on this, but this may change in the future. One of the first practices we need, you actually need to know where the building is in the real world, but at some point, your design has to be built. That's the point of designing a building. So you need to localize it. Unfortunately, the software tools back then and also today, most of them cannot handle global positions. So that's why you usually work with a local point of origin, and it's advised that you should put it in the lower left corner so you won't have positive values. And you should not rotate it according to the map. Meaning that you can actually, if you have the global position of the point of origin and the local XYZ value, you can actually easily calculate and add up the global positioning as well. That is useful when you are going to position it in a map and work it also in a GIS environment. Today, actually, with IFC4, it's possible to this information about which sort of map are you using and your rotation that you shouldn't rotate, and also your position. You can actually use the EPSG code for doing that. So before, with 2x3, you actually had to give that information in addition to the model. Now you can actually, it can be part of the model, which is very useful. So we also had some rules about stories. Every building should be split into stories. The whole project, actually, all discipline has to work on the same stories, building stories, and all objects has to be allocated to the correct building story. That's for many different reasons, but sourcing, filtering, finding information quickly. If there are objects that are delivered that are taller than one story, if nothing else is agreed, it has to be allocated to the lowest floor that it is bound to, or included in. Another very important part, this is about identification. In order to identify, actually, if all objects or instances of an object that have the same defining properties, they are actually have to have the same object type code and should be identified as the same type. This is very important for example, for communicating between designers and contractors, so contractors easily know how many occurrences of this type is there for cost analysis, for example. That meaning, for example, this case we're showing here, you have an internal wall, external wall here, insulated wall. That is, of course, two different types, even though it looks like it's one wall. Same with the slab, same with other kind of walls. If you have different defining properties, it should be split up between those. But all these are, if they have the same defined properties, they should have the same property or the same type name. So yeah. We also have some rules that actually came in the later version, because now we want to also see the opportunity to have buildings into municipality maps, for example, and property databases. So we made some rules for that the building envelope, which is primarily what you want to see, also maybe some slabs, but except from that, you want actually all other information sorted out or filtered away. So we have made some rules here. I don't think I have time to go into the details here, but it's this kind of agreements. This is just, we just agreed this is the best way of doing it, unless something else is advisable in this specific project. So this is what we landed upon. And this has been the Norwegian Mapping Authority, Kartverket, who actually advised us to do this. So we actually relatively well organized and well represented in the industry. Actually, yesterday in the regulatory room, there was mentioning about why don't buildingSMART International make a rule for how you locally can make your own properties if you don't find it in IFC. Because IFC is international, it does not cover all aspects, all issues that you need in your local industry. So we did that. We actually did that as way back in the first version in 2015. So first, you have to check, is it in IFC? You use IFC. That's the law. But you can make new properties. If you have to make new properties, you don't put new properties in existing property sets. Then you're messing up the structure of IFC. So you have to make new property sets, and you have to identify the property set not using the already used P set or quantity P sets, or if you already have a project ongoing in buildingSMART International for extending the P sets. You can also use EP set, but you should not use those. So you have a local code in the beginning, and then you have up to 3 letters, all capital, in order to have a prefix that clearly identifies the country and the context or the owner of who has developed this and who is maintaining this, taking responsibility for this. And then you can have a name for the property set, should be logical, so it's understandable, the context. And we use English in order to harmonize and communicate. So it's easy to, if we see this is a good idea, and after some time, we can actually use the same as an input to buildingSMART. And then you can have this is your property, this is where you use it. Now we have that, then we actually see that IFC is not really very good at dividing between if the property describes what is the designed requirement, which is the minimum value this product should have for the building to function, or the property of the chosen object or product by the contractor or the designer, because there actually may be a difference. If you have like a wall in a corridor, and you can have different acoustic requirements and fire requirements into each of the rooms, but the contractor may choose just to build it with the highest requirement all the way down, simply because it's easier. But you want to refurbish after 10 years, you actually want to see what are the requirements. So you don't always build with the highest requirements. So we need to differ between those. IFC does not handle that. What we have settled on is that the value in IFC, the IC value, expresses the property of the chosen object. But the requirement, we actually make a new property. So the fire rating on this door, we use for the chosen door from the object library or for the design door. It is actually, that is the IFC standard. But the fire safety engineer, the requirement from the fire safety engineer will use the own requirement here. And since it's a requirement, we have actually also agreed on a suffix, because not all BIM viewers actually are showing which property set the property comes from. So if we just say fire rating, for example, you would actually not be able to see whether it's the P set or the fire separator. I'll come back to where this came from. So we also agreed that it should have a rec in the end, so you know that this is the requirement, the minimum requirement. You cannot replace it with something else with a lower value. This is important for us. We also identify, when you are identifying products, let's say, for example, we always talk about walls. Walls are actually not the best example, but in this case, walls are good because they're actually composites, and they are consistent of very many products actually. In this case, I have an external wall. It's cladded with some wood on the outside. It has a plasterboard on the inside, and then it's insulated and has vapor barrier and so on. And how you are defining it the process for defining in unique buildings, typically you will have a way where you start with the outline, and you maybe just use one external wall or maybe one internal wall. And the more the project matures, the more you know about the properties of the buildings and the requirements on the spaces. So you also develop your objects, for example, your walls. In a closed value chain, that what I'm describing here, that is how you are maturing the projects along. And actually, even though you're down here on coordinated design, if you haven't found your subcontractor who's actually going to build the wall, you don't know which products it actually represents. It just represents some properties, but not necessarily the product. In the closed value chain, it usually can be, for example, house builders, where they have vertical integration. They have their own designers who use their own designing tool, who refers to specific products because they already have agreement with the subcontractors. And so even from the beginning, it can actually not just be properties, but it can be actual products. So, and it's not either or. In most projects, it's somewhere in between, that maybe some products are very important, so you focus on that and you're defining those early stage. Others you may wait because it's not that crucial for the building's functionality. But it's important that you know this and you can communicate this within the project. So you know, is this just, are we maturing? Are we actually don't know much about it? Or is it actually settled? Because it says something a lot about, again, identification, especially about the cost and about the life cycle analysis and the life cycle. Yeah. Then we also have two different ways of object type naming. This is again identification. And we didn't invent this. We just expressed and explained that this is already going on. The object type naming method 1 is that for each set of defining properties, there is one object type name. You do not have more alternative properties within this one. If you change one of these, it's a new name. That's method 1. Method 2 is more flexible. We see a lot of this. So you can say this is defining properties of the object type, but in the method 2, you can have defining properties on the object occurrence. So in this case, this one, 02, is actually just that it's external and it's made of massive wood. But the opening direction, dimension, thermal, transmittance, fire rating, color may vary, and you can have a subtype, 0.1, 0.2, 0.3, further on. Why is this important? It's important for the contractor who actually are using the BIM as a foundation for their cost analysis, to know is this actually all the information that am I given here, or do I actually need to look into the different occurrences for more information that may actually affect the cost, and of course what should be procured and delivered. So this is important. So this is actually about a communication. You had to communicate how are we using in this project, and all disciplines should use the same method, preferably. We have also tried to standardize, or at least provide some information that's already known, but what we call a compliance level 2, just so you know that what we mean by compliance level. Compliance level 1 is that the data exchange support is supported by current version of IFC. Compliance level 2 includes IFC and use of a data dictionary according to the international standard. And this is more for vendors, software vendors, and object library vendors, so they know how to what is classified and how the classification actually works. We also have some, this is an informative appendix that also more like introduces a generic methodology, but mainly a set of terminology in order to communicate how are we working in this project. We differ between acceptable and not acceptable deviations between what is actually designed and what is built. You have different processes. You hopefully have a quality assurance process. We're introducing this here, that you should actually quality assure that what is being built is according to design. A lot of changes are usually made, a lot of decisions are made during a construction. At some point, a deviation between what is designed and represented the model and what is actually built can be acceptable because the model can still seem to represent it. In other terms, what is actually being built looks so different that it's not representative. The model is not representative anymore. So you actually either have to rebuild it or remodel it. We also introduced the concept model control, which is a continuous iterative process. Model control is at a milestone, you actually have more documentation that you have delivered according to your requirements. As-built model, we already talked about that. Some BIM functions, different roles you have in the process, and then we have the process status code. I will come back to that later. That you have something we call control volume. Larger buildings are often divided into volumes because you don't control everything at once. It's very difficult to control and manage. And then what we also have here is a generic process that Statsbygg has implemented for automatic validation or model checking of the model quality, and this can both be of geometrical information and alphanumeric information. Yeah, it's an informative appendix to the part 1. So introducing those, so we have a more specific terminology, so we don't have that many misunderstandings. This is an appendix to the 8360 part 1. Yeah. So this is part 2, which is how you are actually using the classification and identification system that Gunnar was talking about, and use that in relation to models. It was developed or renewed from the more like industry standard to become a Norwegian standard, with the mindset of working digitally. But it does not mention use of BIM actually. So this standard identifies how we're actually going to use it. It's been developed by Shaliva, sitting there, who was also leading the committee before Gunnar took over from the classification committee. This is about the importance of identification. Just to stress Gunnar's point, building are complex. Documentation can also be quite complex, whether they are analog or digital. So what we want to do is to combine and use the model which is, in my view, a geometrically distribution of data to see the resemblance and the representation of the building, and actually have the added information that makes it easy, because you can identify it and look up the information you need to. So this is where also the model brings in a new aspect, that it's an intuitive way of finding more information about your building. Also, you don't have to go to the building to find the information. You can actually look it up on your screen in your office. So actually the original version, tværfaglig mærkesystem, cross-disciplinary identification and tagging system. I think that was my own interpretation or translation, which has a history way back. I think it's from German nuclear plants. It's a DIN norm, BIM standard originally, that later on was developed into this one, so it is somewhat in accordance to that. When they wanted to make it a Norwegian standard, they looked at this one and tried to approach it as much as possible, but since it has been used in Norway for, 20, 30 years, it was actually difficult to change it 100%. For example, for system codes, which are numbers and not letters, but it is mappable with the ISO standard. So I just brought some more numbers here so you can see how it's actually being used. And also, as Gunnar showed you, there is a that should be sorry, location, system, component, and component type. Component occurrence. This is wrong. It should be location, not sorry. It is right. It's location of the system, not the component, because that was actually where you used it before. You actually had the room that the component served very often in the beginning, and that messes up how databases work, because you start on the lower level, and then you actually later on in the system idea are having a wider scope. So that was a difficulty. So now it's the system location. So it has to be bigger than the system. And then you have the system ID. Then you have the occurrence, and the occurrence comes first, because maybe you know you have to have something here, but you don't know the type yet. And then comes the type. This is how we're using, and we're using the same prefix as in the ISO standard. So There are different levels. You can have the aggregated string. This I took an example here from Startspik. We don't use the top node in Startspik, so you can actually also have the plus here, just not plus plus. You can have the different parts here, as I showed you in the previous slide, or you can actually, what we prefer, to have every data field separated, because this is what it's about. It's about data. So we actually need to stop thinking like this and think about it as data. And this is kind of what's brilliant here. What you have seen here is actually also here we made standardized properties for these. So on level 0, you have it's just called ref string. It's then you have the 4 levels here: location, system, occurrence, and type. You have here, and then you have all the different separate data fields here. It's called reference. You see, it uses the same methodology that we advised in regulated in part 1, NONS, Norway, Norwegian standard, and then call it reference. And reference means that you can actually also use the ISO standard, or you can use co-class, or you can use CCS, or whatever kind of classification you have. So this is actually something we want to share with. If you have the same, why not use the same? Because then it's much easier to talk together and have the same experiences. And then there are, of course, additional code properties, because there are different uses and uses from before. And so we use our code this way, and we use the code our way. For example, I told you that the location is often the room that is served, and not the container for the whole system. And so they still need their room. Yeah, okay, but then you actually have okay, the top node identifies, and that is, for example, the room here. You also have a possibility, if you have a complex, a campus, many different buildings on one side, you can actually identify the overall complex here. And you can also have a system, take an elevator who has power supply, but it also have internet access or some other automation access and so on. So you have to choose one primary system, and then you can have secondary systems that is attached to as well, and identify those. And we have a system for that as well. Yeah.
Do you want this code inside the object, or you want sometimes it's a relation in an IFC file?
I think we need to, for those who are online.
If you use this coding system in IFC files, for example, then you can have like an air terminal, and then it can have a relation to this room, but the air terminal does not have the object property inside the air terminal itself, but it's the relation definition.
The air terminal would be part of the system, and in this case, you can see that it serves this room. This air terminal serves this room, so you can have the code of this room in this property.
Okay, yeah, but it's actually also a relation.
In the model you can have a relation, but this is another way of
this is in the next step for asset management.
Yes.
Okay, yeah. So you can search for it. You can search for the relation and then use the name of the room
for automation. Automate the input here. That's a very good point, and I think Gunnar will end a bit about the potential that we see in harmonize or mapping a different classification, where IFC is also a classification with its relations and how that can be utilized. Yeah.
Thank you.
Okay, I think I need to rush on. There's a lot to ground to cover here. The old system, I don't think you should turn it off. The old system actually had 2 strings, one for what is the type, and one is unique for the occurrence. We actually identified those with historic strings. Usually we didn't think about data fields back then, so separate data. It it all has just this aggregated string. But we are going to living with those two versions for a long time, because we have buildings that have been using this for 20 years or 30 years. So we need a way to map the old 2 strings with the new 1 string. And this is actually, in this case, I just took this code for component occurrence, which is one of the strings, and just showed you how it can actually be mapped either directly or with some kind of interpretation that in most cases can be computational. So just by have a small script, you can actually use them together. So you can actually work, for example, in a more new context with old information. Then we have part 3. It is not published yet, but we are getting closer to publication. So this is a fake cover. I just made. I saw Stefan in the crowd, so it's not. I know. I made this. Hopefully soon. And it actually to use this, how you which requirement do you have to documentation for the building and landscape, surrounding landscape, as Gunnar talked about. And I would say that the core value in this standard is identifying the entire asset information model, which both have structured geometrical information. It has structured alphanumerical information that is outside of the geometrical information. The geometrical information can also have alphanumeric information, at least the parts that is used for identification. And then it can also have more like documents and files, drawings, other PDF kind of stuff. And then you can have different ways of communicating. In some application, it will be one way that is derived from the geometrical model or the structured alphanumerical model and becoming more like a document. But in some cases, at some level, it can also go the other way. And you have 4 different ways of referencing. You can have direct relation within that is proprietary to the model or the database, the system that you're using. You can also have an identifier that can, for example, be the system that we talked about, this TFM or NS 3457 part 7. It can also be a machine-generated grid. Then you have the hyperlink, and then you can have API. So there are different ways of doing this. Where am I saying? Yeah. One of the things that we have discussed is that in the geometrical model, authoring tools today are not very good at handling alphanumeric information. It requires, often case, several different licenses, a lot of skills in how to use it, and IFC exports can be quite difficult to set up correctly to get the properties right. So it is actually advised that for facility management and operational maintenance purpose, you do maintain the geometrical model, and you do maintain those identifiers, whichever one you're using, also with a future perspective. And then you actually, all the other alphanumeric information you want to maintain, you have that in another system that is easier to use. You may have, there may be some information that you say is so crucial, I need it on the geometrical model. And we have advised some of it that are specific for operation and maintenance, very much focused on the product and the relation between the owner and the vendor, like warranties, scheduled maintenance, who is the vendor information and such. You may actually want, and if you do that, we recommend that you use these. There are actually some we didn't find in the IFC model, and we have now proposed our own property set and properties. Then we have part 4. It's still draft. Energy analysis. It's actually a collaboration with Statsbygg, where I work. We have also developed a requirement set of energy analysis together with this. It's already in use, but it's part of the same work. And the part we are identifying here is, or standardizing here, is the handover from the architect to the energy analysis consultant. And this is important because the energy analysis consultant may not have been identified in early stage where you are starting to design the building. So this can actually be a requirement that the client or the turnkey contractor includes in their requirements to the architect. And so they are actually pricing their services correctly. And then you have the energy analysis consultant afterwards, and they still get the information they need without quarreling about additional pay and so on. And the first part here is simply model validation. Does the model have the information I need? And the second part is, does the energy balance, is that in accordance with the requirements for the overall performance requirements of the building? And we have identified the objects that has to be in it, and the properties. Actually, not that many properties. It's basically just the occurrence and the identification of the objects. And we have also identified over the development of the project either something that should or shall be included. So yeah, and then the modeling practice, it is based on the part 1, the 8360 part 1, but there are especially 2 property or requirements that are very important here. Division objects per building story, if you remember that one, and also to keep relationship between objects, and especially objects next to rooms, spaces, because it always it sees if a window or a door or a wall have a space on the inside and not on the outside, then it is external and has to be calculated. And then we are now thinking about this is this is the guideline we have split out. It was actually an appendix of part 1, the 8360 part 1, which now for common Norwegian properties, which is now become its own guideline that we can renew ideally annually when we have get some more experience using this. So it was actually initiated by Sykehusbygg, the last client builder, Statsbygg, the government client and owner, and the Norwegian railway client and owner. And we put this in as a proposal, and it was processed and added and changed and so on. And now we have a pretty good understanding of this. And this can actually this is well-known practice. Sorry, I haven't translated this one. For example, duplicate owned by, you typically have a toilet in the architect model because the toilet wants to decide where the toilet should be. The toilet is actually the plumber engineer's responsibility. So the architect does not provide any information more than this is where the toilet should be. So it's just a replacer, but it's actually owned by, in this case, plumbing. So this is actually how you can tag that, yes, we know it's in this model, but you have to find more information in the other model about it. We have a lot of process information also. Process status is one of them. These are the property set that we have developed, and the properties for identification of digital models, which I've been quite thoroughly through now, it has been one of them. Process status, we need actually to be able to know the maturity of down to an object level. Very often this is identified on the volume. If you remember, I said you bigger buildings, you have controlled volumes. You say that this east wing or this floor or this building story is one volume that we do the checking, and when we have done the checking, say now it's okay for the next stage, it can actually get a next level. This is very important to know. For example, between designers and contractors, is this mature enough for a quote? Is this mature enough for construction? Has it been built? Okay, it has been built, but it has been approved by the builder or the client for takeover by operation and maintenance. That is actually very important. So it doesn't mean that all projects has to use all codes. In the project, you actually have to design which codes are valuable in our project. Smaller projects usually only have to use the main stages. Is it coordinated design, production approved for production? Is it approved as built and such? But in larger projects where you have many different actors and you don't necessarily know where everybody is working at the moment, it can actually be a good idea to also utilize some of those between. Those are more like milestones. This is more procedural, like information and quality assurance control purposes. You can add your own between. You should not rewrite these. You should use these as they are, but you can make your own in between. And of course, they are set up with a number of requirements. And the requirements is both for the model content, but also includes the processes around it, for example, quality assurance and decision making. So this is a coding system that is actually, this is not the MMI. This one is actually not a Norwegian standard. It's a industry standard that is developed by initiative by the contractors, but it's a cross-disciplinary effort, and actually been part of the group as well. But the process status as such, not the specific process status system called MMI, Model Maturity Index, but process status is identified as both part of the process property set and as a status code. And you just use the code. You don't say, for example, MMI 100 or anything. It's just the code. So it's directly in relation to another standard. Then we have triggers. This is a bit tricky. At some point, someone found out that if you can actually have a Boolean property of certain constructions or building elements that can trigger an extra set of requirements that this object otherwise would not have. If you take, for example, a LAF bench, something you typically have in laboratories. It's a closed environment where you have suction of air, you have your own light, you may have gas, oxygen, and other gases, and you have a sink that has to have a drain and hot and cold water. It's actually a small environment by itself. It may actually be provided by the architect, but it needs actually a lot of connection. It needs plumbing, it needs mechanical, maybe actually have building control, data connection, electrical connection as well. And that means that this component needs the attention of someone else. So the first function of the trigger is that somebody else has to look at it. So actually the plumber should look into, for example, if the architect model has true or false, has plumbing connection. If it's true, I have to look at it. And then it triggers, if you have plumbing connection, you can actually, or let's say the building control connection, you can actually, it opens up for a number of properties that you can actually, which kind of connection is it, and protocol, and who's it controlled, what system is it controlled by. So this is a functionality. We don't have a lot of practice with it. So it's at this point a bit academic, but it's a possibility. So just know it's there, and we have developed it. Another thing, and I'm going in for landing now, don't worry. we have actually also seen the need for what we call conditioning discipline, premises discipline or whatever. It's actually a discipline who does not have direct ownership of any models or objects themselves, but they have input to the performance and the requirements to objects in other models, to other discipline models. And that can, for example, be fire safety and acoustics. In Stadsbygg, we have also identified other for like material and thermal resistance, acoustics, and so on. Environmental. But in this case, what we have standardized here in the guide is actually to promote, if you have a project and your fire safety engineer or your acoustic engineer, they are actually making their own model, and can be a good idea, because if you just put your requirements in a note, a report, it can be difficult to actually evaluate whether each object is according to the requirement. If you put the requirement into the model, often the architect model, first of all, you have to be very careful to move around with objects in the architect model, copy doors to another place and so on, because you're messing up with the requirement. And also it is a source for errors. So what we do here, this is actually an example that Shaliva was leading in a hospital building. The pictures here, where you have like thin walls, so it didn't interfere with the surface of the architect wall. It was actually a copy of the architect, but you have then you have this tag that makes it easy to point to for fire rating and for acoustics. And you could actually have your fire rating requirements in this model as well. And you actually see this is actually the exit route, and this case is actually the tagging for the requirements on the doors. So you don't actually are drawing the doors, but you put this on the floor, and the door has this swing out that collides with this tag, so it automatically checks the content of this tag with the property in the door. So you can actually have automated model. And this doesn't change. This is owned by, these models are owned by the fire safety engineer and the acoustics engineer. So, and for this we have had to invent our own property sets and properties as well. So that was for my part, and then Gunnar will take over.
All this information classified, identified, and a whole lot of standards seen as a whole. This is from an earlier presentation from Steen. I borrowed this one, but this is, as he pointed in his presentation now, that using the series of standards 3457, 3456, and so on, a lot of people read it as a string, but it's actually data. So here is also an example of using the 3457 in BIM. So the 8360-3 that Steen had a fixed front page is showing how to connect the information. So this is the table from the 3456, as that's the information standard, using the codes and how to connect it to the IFC zone, IFC room, and so on the building and the plot. And also how to connect the information about the systems and the components and building parts. So that is how this standard 3457 is connected to 8360-3. I was going to present a mapping system, but the computer is fixed and we don't have time. But this is what Standard Norway and Kjell Ivar, that we have talked about here, has mapped different standards. This is the Statsbygg project standards and the Norwegian standards and so on. And the colors here, this yellow is it's the same. It means it's not always one-to-one, but one-to-many and many-to-one, but it's the same type, same component, same system. The red, that's where this thing, the central thing, this object is part of. So here it's the same, and here's the part of. If you remember, I pointed the mapping earlier, going from the building part to the component and then the IFC. So why all this information? Why this classification? Why this information? And this is how I see this used, using the standards. This is a school. The public buildings is required by regulations that the scouts, school bands, choirs, so on, they can use these buildings at the evening and the weekends. So they can book this building online, and to use the building, they will have to open the doors. They will have wayfinders to get to the room they are borrowing. They will have the end user information, how to use the rooms, and how to use the objects in the rooms. So using here the standards, I can connect these dots. The same building, the school, with the systems and the components and the guidance, the sensors and so on. If a sensor in this building detects a critical fault on the fire alarm system, it should close the school, so I can't book it, or I can't open the doors to get inside. Using the identification of the building, of the system, and a component. And when this fault closes this building, it also should address the maintenance crew that when you are now working with the fire alarm, you can also take the roofing. Today, without this information floating and connecting, I will use this building here. This is football camp, Norway Cup. The 600 children sleeping in the building when there are hot works with open fire on the roof. Not using the information right. So using the standards, I could get this thing to float. No questions? Everything was clear? Everything was clear?
I have a couple of questions. One is for you.
Yeah.
So how long takes to digitalize all your existing assets? So for your municipality, for example?
How long will it take to get it into the existing facilities?
Exactly. So
Yes.
not thinking only the new are coming with the new structure, but how do you do?
This I don't have exact time, but we will use the facility management, because now when I have the yearly service for the elevators, for the fire extinguishers and so on, I have in the contracts with the vendors, with the suppliers, that they have to encode the information according to the standards. So in 250 schools in Norway, in 18 months, we had all the information about the fire extinguishers. In 14 months, I had all the information about the playground installations. Because using the top node with the complex and the building and so on, we can gather that information. And that is one statement, because a lot of the projects, they have only this building or this project in mind. The finance department has this project in mind, but the facility management, we will have the building, the system, the component, and the complex. So with 250 schools, I will have to use the whole string and use the information.
It's okay. And another one is for Steen. So you have shown your approach for level information for properties, maybe. But do you have another approach for the level of geometry, similar of the level of information needed, detail parameter, like the standard 17 for 12 or?
Yeah, you're talking about geometrical detail?
Yeah, exactly.
Yeah, we haven't standardized that. We develop it in Stadsbygg, where I work currently, but we haven't standardized that yet. But it actually may be a good idea for as an issue for further standardization. So thank you.
This where you had this labeling of the fire rating, so that is a kind of perfect use case that we have been thinking in this properties API, so that you could actually, like in a CD, you could add new properties to the component, so that it would be nice to have a chat about that, like how that could be implemented.
Sure. I think we should actually start to look into these national standards for additional requirements, and maybe not so much what we call it, but more the practice around it, so we don't have a lot of varying practices, so it will be easier to harmonize in the longer run. So yeah.
Yeah, the idea there would be that the engineer who is like assigning those values don't need to create their own IFC model. They would just be adding that information to the IFC.
Yeah, we have specified different kinds of methodology. Also in Stadsbygg is not standardized.
Yeah.
That one thing is simply just to put it into the model. Another thing is that via a report, or you can put it into a model because you give access one way or another. For the fire safety engineer, for example, but you don't want them to have access to the whole model, so they can actually change the architect model, and that is one of the challenges here. And then you also, the third level is that they make their own models. So, but if we can find an interesting way to actually apply properties without having to make separate models, that could be very interesting.
Yeah, I think that is something that we could kind of.
And also without that, the what we call the conditioning discipline have to get access to the entire model, just those information that they are responsible for.
Yeah, basically, of course, they can view the whole model.
Yeah, sure, but not edit it.
They would add information that they own.
Exactly.
To the model.
Yeah, very interesting. Yeah.
Right.
Okay, thanks a lot.